Hello, Cheers Kevin here, and welcome back to Minecraft Agoraphobia. And this episode is going to be fun. We are going to rapid fire write a bunch of EEPROM scripts because we've got a whole bunch of bots that have jobs to do that I just haven't gotten around to making them do. For one, we have a cobblestone generator up there, and right now I have my big fancy robot doing some cobblestone mining. And really, I'd love my big fancy robot to not have to be doing that. Now, where this cobblestone mine happens to be, I mean, we'll probably eventually move it to somewhere else. But right now, this program is working. And if I go ahead and stop it, it's actually, you can see it's filled up the robot's inventory. It's now throwing stuff into this chain of chests. I did calculate the amount of cobble it would need to build all the walls up to, I guess, 186 blocks high, from higher than the top of our base thus far. Well, if the perimeter is 64 blocks, so we need 186 stacks. So we have 4 chests here, gathering cobble up slowly as this farm goes. And of course, I put a charger here just so that this thing would go. I also, if we open it up real quick, come on, right. Control-Alt-C will force interrupt. I also just added this little bit here. I said, well, the robot durability is greater than 0.25 because right now it's using my diamond pickaxe, and I don't want that to go to, I don't want to lose that. But this will make sure that it actually stops when we get to 0.25. But yeah, I want my robot back. There's nothing that this robot, no upgrades or anything that are special about this robot. So I built a new robot. This is Rinsler, and it has a CPU and memory. And that's it. It doesn't have inventory. It doesn't have anything else because it doesn't need inventory. This stuff is going to fall into a hopper. I want to write an EEPROM. It doesn't even have a hard drive in there. We can write an EEPROM script to do that. Also, we need to, we've been, I mean, it's been a couple episodes now. We have had these microcontrollers sitting here ready to flush wheat and whatnot. We have a drone that is sitting in a chest up here that really ought to be harvesting wheat. Where's the drone? There we go. Rosie. Rosie has a job to do. And then finally, we have snuck back here, Shaky. Shaky is, well, was originally going to be used for inventory management, but because that job seems to not be working, our script for that doesn't seem to be working right now, I'm going to put Shaky on the whole feed the sheep patrol, which is a job we definitely need to get restaffed on because I just had to go do it myself because in building another robot, we ended up low on power again. So we've got a lot of scripts that we're going to try and rapid fire right today. I'm excited. Let's get started. Okay, I'm going to create a folder called EEPROMs, and we're just, I don't know, I think we'll start trying to put some things in there. Eventually, we need to organize this repo a little bit better, but let's go ahead and create, so there are some that already exist. Water is already an EEPROM. Storage, I think, yeah, storage, I think was an EEPROM, or maybe that was a, no, that's not an EEPROM. Power station is an nope, that's not an EEPROM either. But what we eventually want to do is probably use EEPROMs because there's no reason for us to waste hard drive space if we're not going to end up using it. If we have single purpose robots or drones, there's no reason for us to be throwing extra components at them. So, okay, let's start with the cobble one. So we'll call this cobble.lua. And we're going to say local robot equals component proxy. And this is basically just the way that we get the methods for the component with a component dot list robot, and call that, and there we go. So now we have the robot API, and remember this is the lower level robot API, so it doesn't have things like move forward, but it does have things like move, and you have to pass the argument explicitly. Now EEPROMs have to run forever in theory, unless you want your machine to turn off for some reason. So we'll say while true do, and then inside here we're going to toggle back and forth between two states. We're going to check, we're going to do basically what I already had said. So we'll say while robot durability is greater than, and I could just say 0.25 here, but if you've watched me for any period of time, you know that I hate random numbers that are just sort of sitting there, not explicit. So we'll say min let's see, stopping durability. And I'll set that to 0.1. If we're down to 10% durability, I don't want you to keep mining. I want you to stop. And I don't know, in theory, we could eventually change that. We could probably one day, we might at 1.5, one day we might find some reason to say, okay, we'll just replenish you with cobblestone pickaxe with stone pickaxes or something, and so then we don't actually care about durability at all, because we'll funnel some new pickaxes into a chest underneath you and say, okay, whenever your pickaxe breaks, go ahead and grab a new one or whatever, and auto farm that way. But for now, we'll just say if it is while robot durability is greater than stopping durability, then we want to do the actual mining, which is just going to be if robot.detect, and that's going to check if there's something in front of you, then robot.swing. And then whether or not we ended up breaking a block, we are going to sleep for 0.2 seconds. Okay, now sleep, of course, doesn't exist. We're going to have to import that, but we've already written a version of that, so that should be fine. Then mode 2 is going to be waiting for the durability to be better, right? So we'll just say, while robot.durability is less than or equal to stopping durability, do. And actually, an important thing to note here is it is possible for durability to return nil if we don't have anything equipped, so we'll want to make sure to handle that case. Sleep, I don't know, let's say we'll sleep for 5 seconds every time that we're just waiting for a new tool. So let's import the sleep command, which I think we have in water. Yeah, there we go. Computer pull signal timeout. Function sleep until the timeout, computer pull signal timeout. And actually, I realized looking at this code, this sleep code, that there's actually a bit of a problem with it. And I don't know why I didn't just steal the original initially. When we're using computer.pull signal to actually delay, but we're delaying for the timeout, and we've got that in a repeat. Now, in theory, that should never be a problem, but what we really want to do is delay until the deadline minus the current time. And that'll make sure that we repeat in here, but we're not going to say, oh, if we say I need to sleep for 5 seconds, and for some reason it sleeps for 4.9 seconds, then this repeats again. It's going to say, okay, sleep for another 5 seconds. No, we want it to try and sleep for 0.1 seconds or whatever. Okay. So that sleep function is now fixed. And the last thing we need to do here is do this durability fix. The only thing is, I'm going to just make this a while true. And we'll say if, let's see, local durability equals robot.durability. And this is just so I can avoid calling robot.durability twice, because I think function calls shouldn't be made more times than they have to be. So we'll say if robot.durability, if durability is less than stopping durability, or let's see, no, if durability equals nil, or durability is less than stopping durability, then break out of the loop. Okay, otherwise, then we're assuming everything is fine. And then we can do the same thing here. So while true, do, we'll just copy the same code. Oops, copy it, not yank it, not delete it. Durability is that, and then we'll say if durability does not equal nil, and durability is greater than stopping durability, then break. So we have these two loops. The first one is saying, hey, until our tool is too worn out, continue to just perpetually break things. Otherwise, go ahead and just wait until we have a tool that has enough durability. And so it'll jump back and forth between these two things. So this is our cobblestone miner. And as far as I can tell, it's perfect. Alrighty, Rinsler. I have to jump to make sure to, well, actually, I can just place them like that. So boom, there we go. And Rinsler should now just work, assuming that there's a tool. So boom. Nope, does not work. What's wrong? Okay, Rinsler does not work. I don't know why. Let's put our superstar back in place, and then we'll just try running this not from boot. We'll grab the same script. Okay. Robot detect actually requires a side if we're using the low level robot detect. If we go ahead and run this now, no, same problem. Well, problem a little bit later when we actually try and break a block. Yeah, so you don't get the defaults there. But I think those should be the only two issues. Nope. Yeah, so component and computer I had to require because we're not in BIOS land. But the two issues were just that we actually need to specify the side to detect and the side to swing at when we're using the lower level API. So I'll get that fixed up, and then we'll reload Rinsler and get him working. All right, Breitenberg, thank you for your help in debugging that problem. You can safely hang out here for a moment. And Rinsler, it's time to get back to work. Nice try, dodging, shirking your duty. Go ahead and toss that there, and go. Brilliant. All right, dumb robot with very little. I mean, one stick of low-level memory and a CPU, and that's it in a computer case. And now we have infinite cobblestone. I mean, not infinite because we need to replenish the tool, but we no longer have to worry about that. Okay, next, let's get, now that we have Breitenberg, I can use Breitenberg to spec out what our situation is going to be here for feeding the sheep. And the idea is that every 5 minutes, we want to make the rounds and feed the sheep, because that's how long they take to become willing to breed again. All right, come on, Kevin. There we go. And the plan is going to be, the robot starts over there. It goes over to the chest, picks up anything in this. Okay, I've got random stuff all over the place. Okay. Really? Do you mind? Okay. We're going to go ahead and do a similar thing to what we did before. We're going to say that we're going to have wheat taking up all of these, some number of spaces. We're going to have seeds taking up some number of spaces. And then what I'm going to do is I'm going to say anything in this bottom row, if you see anything there whatsoever, you need to pick it up and take it immediately into the lava and get rid of it. This is going to make sure that our hoppers never get so clogged up that we can't get any wheat or can't get any seeds. And there we go. Now that is full up. So in theory, everything should gather here. What we're going to do, so as the robot's going to come over, open the chest. First thing it's going to do is grab anything in these slots. It's going to pick anything in there up and then immediately hop it over to the lava and get rid of it. Because we only need a stack of 64 at any point in time anyway, so we can just clear out anything that ends up in our inventory. Then we'll go back to the chest, grab anything, fill up as much wheat as we possibly can. Actually, we can do that all that in one step. So then we'll drop stuff into the lava. Then we just need to go around, do movement, and that can be a single move command because we can have a move command that yields, and the yield will just be feeding down. So let's get that one going. All right, we're gonna call this one Slaughterhouse. Because it's brutal. Let's be real. Okay, are we gonna have some? Yeah, I guess we are gonna have some sleep, aren't we? So we need our sleep function. Thank you for the sleep function. We're gonna need the robot function, and we are gonna need, or the robot component. We are also going to need the. Oh, you know what? Actually, we're gonna need our move snippet. That's gonna be pretty big. This one maybe, yeah, we'll have to see if we have to worry about size at all. We don't have stopping ability to worry about. We are gonna need the inventory controller. I'm gonna call that in, so I'm gonna say component.proxy, component.list, inventory controller. There we go. And because this one is going to potentially be long, I'm gonna create a function main, and then I will call main at the very bottom. And now let's grab in our move snippet. Yeah, so this is a fair. Now that we've beefed this thing up, it's kind of fair. And in actuality, I realized that the whole worrying about the drone stuff, that's not going to work anyway. So, but we won't worry about that. Because drones move differently. You can move in multiple directions at the same time. Or along multiple axes at the same time. But anyway, we could probably at some point go ahead and shrink this up a little bit. So main is going to be while true, do, because every EEPROM just needs to do something forever. So I'm going to assume that we're going to be standing on the charging station facing the chest and the lava. So the first thing we will do will be to move 1, 2, 3 forward. And then we need to do chest stuff. Then we need to move forward, and then we need to ditch junk into the lava. From there, we just have one very long move command. And one thing that we can actually do, which I think is kind of nice, is you can have move commands work just like this. you can have multi-line. Sorry, you can have strings rather. You can have strings like this. And although we actually will need to update our move to handle that, we'll need to make sure to remove white space from the path so that if I said, for example, move 2 forward and then left and then right, that it goes ahead and just pre-processes that to 2FLR before throwing it into our interpreter. So let's not forget to do this. Strip white space. Okay, so the first thing we're going to do is we're going to turn around, so 2 to the right, and then 2 forward, and then I need to basically track out the rest of the movements, but this puts us, let's see, if we've turned around. Okay, now here's a fun idea. We can use yields inside of yields, if that makes sense. So I'm going to have a yield be process the cage, okay? That makes sense. There's no reason to do that. Yeah, I mean, yeah, there sort of is. It reduces some duplication. Okay, so this in theory puts us on top of. Let's see. We're there. We turn left. Okay, this in theory puts us on the top of one of the cages. So basically, what I'm going to say then is yield, and then I just need to navigate to the beginning of the next cage. And navigate to the beginning of the next page, et cetera, et cetera, et cetera. Let me go ahead and paste all that in. And actually, conveniently enough, we have the old version of this code, so I can go ahead and just steal these commands. The only difference is that, hey, we don't have to worry quite so much. So yield, and then 4FL, and then yield, and then 7F. Okay, I think this is vaguely, I mean, very vaguely, how this is going to work. Although, actually, one thing that we do want to do, is at the beginning of this, we will equip, and then at the end of this, we'll unequip. I'm just to keep us in a stable situation. Okay, because then we know that inventory slot 1 is the thing that we're actually worrying about. Ditch the junk into lava, strip the white space. Okay, now when we're doing these movings, that we did imply that there's a yield, and so the function there, we can put the function in line, or we can just give it the name of the function that we want it to call, and I'm going to do that. I'm going to say feed cage. So yield is, we're just passing it the name of the function instead of putting the function in line. I'll go ahead and do that then. Feed cage. And actually, I think we can steal that. For the most part, we can't quite do that. We have to say use down 0, or sorry, use 0. And then move forward. And then robot.use 0. We could, of course, do this in a nested way. We could say yield forward yield, with then a function being... well, I guess, yeah, because we don't have bind, so we'd have to do robot.use 0. And I don't know, maybe that's nice too. Gosh, nested yields inside of nested yields. That's fun. Okay, so our equip step to steal more stuff from the from the original power station script is going to be exactly the same thing. So robot.select slot 1. And then inventory.equip. So equip whatever we have in slot 1. Although actually we want to do that before. Yeah, we want to do that at the end here. And then we'll just do inv.equip here to do our unequipping. Now all that's left is for us to figure out the chest stuff and lava stuff. Just because I'm afraid I'm going to forget it, let's get our white space removal stuff going. So let's say F, B, C, and I want to replace white space like that. Oh, that wasn't quite right. Was it W? Oh, I'm sorry. Yeah, no, this was right the first time. Although we can, if we have multiple spaces, that's not going to fix it. Actually, yeah, for some reason it seems to. We can go ahead and just say plus though. Right. So I'm getting confused because Lua has the ability to return multiple values. This will go ahead and swap out what we need. So if we then go into our move script, at the bottom of Slaughterhouse, although in theory we should probably put this everywhere. We can just say string.gsub, and we'll say the path, %s for white space, replace that with a blank string. Okay, the chest stuff we can go ahead and steal yet more. So yeah, we'll say for I through not. Yeah, we'll just go ahead and steal this, right? While true, do blah 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 blah. Okay, so do the chest stuff. For I to 9, we'll say local has count is robot.count. If has count is 64, then break. So we're just trying to get our current slot up to 1. Although actually this does mean that we want to make sure we do our robot select 1 right here. Actually, we probably want to do it in both places because we're probably going to, we'll potentially be messing with our selection beforehand. So for one, we're going to go ahead and grab as much wheat as we need to fill us up. And then, yeah, if available, then inventory select from slot. Okay, sides.down becomes 0 because we don't have sides. Math.min we do have available. I think everything else here we should have available in this environment. Okay, so that takes care of actually filling us up with wheat. Now all we have to do is get any items from the remaining slots. Okay, so we want to say for I equals, and I think it's 45 to 54. Those will be the last slots in the chest. We are going to say, hey, if there is get stack and slot, hang on a second. Does get stack and slot give us back anything at all? Are we going to get a size of 0? Okay, yeah, no, this will give us nothing. So, let's see. So, yeah, we can say if that we can use that to test. So we can use that to test if things exist. So we'll say local stack equals this, and if stack, then. Okay, so then we know there's something that we need to pick up, and we're just going to advance our selection by just saying robot select robot.select +1. We're not going to keep track of it. We're not going to try and stack things. If they stack, we're just going to say, hey, I don't care. Just put them all in here. And that'll mean that 2 through so our internal slots 2 through 10 could get filled up with stuff. Cool beans. And that's all that we're doing. We're just getting all the stuff out. Well, sorry, no, we actually have to suck from slot. And suck from slot 0. So 0 is the side, which is down. And then those slots we know our internal slots, they're going to be empty, so we don't need to give it a size. We're just going to say, grab everything in there, put it in our internal inventory slot. Okay, ditching the junk into the lava. This should be fun. So we'll say for I equals 2, 10, right? Yeah, that's right. And then we're just going to say, hey, if I have anything in that internal inventory, switch to it and then drop it. And actually, you know what? I think this is going to be easier. Let's just go ahead and select them. So robot to select I, and then just robot.drop. And we have to say we're dropping it down because we're going to be hovering on top of the lava. And that is that. I think this script should work. The last thing we need to do is sleep for 5 minutes. Let's sleep for 6 minutes. So time 60 seconds times 6, and that means we need to import sleep because we haven't done that yet. Or have we? Sleep? Yes. Okay, we've got sleep in there. We're fine. Let's push this up and see what sort of train wreck we get. Okay, after testing this for a little bit, I encountered a weird bug. We had this move, yield, forward, yield, and I think actually calling move within calling move managed to break something somehow. I'm not entirely sure why that's the case. My guess is that there may be something to do with the parse string, maybe. I don't know. So there's probably some area in which we are leaking things. In fact, there's a whole bunch of stuff here that maybe is supposed to be local. I don't entirely know the rules of scoping. So whatever. We're not using moves inside of moves. And this seems to fix things up. Otherwise, yeah, we were getting weird pathing errors. But robot use, robot move forward, robot use is how we feed the cages. And then this works. So let's throw it on our dumb bot. And why? Oh, I commented this out for testing. And yeah, get the sheep fed. And actually, looking at this, Shaky has some extra stuff that we don't really need, like the disk drive and the graphics card without a screen or keyboard. Why do we need a graphics card? And the hard disk drive. So I'm going to go ahead and disassemble and reassemble this bot real quick. All right, this right here, this should be all that we actually need. The inventory upgrade, an upgrade container tier 2 slots that we can throw in the inventory controller upgrade, basic CPU. I'll leave the memory tier 1.5 in there. Hopefully it'll be enough. We'll see. And then the slaughterhouse desk. Let's go ahead and build this. Recommended components are missing. Oh no, bootable medium, blah, 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 blah. This is the bootable medium. Ha. All right, so Chiral needs to start right here. And it needs to have the inventory controller upgrade. And that's it. We have the correct BIOS in there. I suppose we can go ahead and just toss in some bad seeds that we don't want to be there because that'll clog up our stuff, and throw some stuff around here just so we can watch this thing at work. And yeah, let me just doop. I don't think we're in the way, but I'm gonna hop down here all the same. Let's go ahead and fire it up. There we go. Chiral is immediately running over to the chest, grabbing excess from the chest as much as possible. And yeah, we'll notice also stealing all of these seeds, saying, hey, I don't want that bottom part of the inventory full. And if we look carefully, you might see some green because, yeah, all of those seeds have just gotten chucked out. So we have disposed of them, and now we are going around feeding our sheep, making love, making sheepy babies, making power for the station, for the chunk. It's going to be amazing. Okay, there we go. Doing well. There we go. Last one, and now all we have to do is come back home and turn around, take that out of our inventory, and just sit around for 6 minutes, and then do the whole thing again. So we now have the slaughterhouse back and working again. The last thing we have to do is get a drone to sit right next to Kairos. So Rosie or Carols, I don't know. We'll have Rosie and Carols doing cool stuff. So the drone needs to go over here, get some seeds, go up there and do some planting. This should be nice and easy. We're going to call this, I don't know, plant. Lua. And you might think that we should be able to steal just a whole bunch of stuff from, for example, Slaughterhouse, right? Because we're dealing with an inventory controller, so we can just take that. We'll have a function main, so we'll take that. And in theory, we can just move 3 forward and then select our first inventory slot and then grab stuff and blah, 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 blah. But unfortunately, no, we can't do that at all because drones, even though I rewrote our move library to, in theory, work with bots and drones, drones have a completely separate API. They actually move. You can say drone, well, I guess would have to refer to the drone. So let's replace that with drone, and we'll place in here with drone. We could, the way that you move is you say drone.move, and then you give it an X, a Y, and a Z. So you say, I want to move 1 in the X direction, and I don't know, 5 up, and -4 in the Z direction. So that's, So you know what we're going to use is my favorite strategy of all time, Future Kevin's problemitis. That sounds more like a disease. Future Kevin's problem pattern. There we go. It's a design pattern. We are just going to write function names and leave future us to write it. So we'll go ahead and say move to above chest. There we go. And I think the reason for this is that drones don't have an obvious forward direction, right? So another thing that's important to note is that the drone move command doesn't actually pause. It basically says, all right, I'm going to start walking in that direction. I mean, I'm going to start flying in that direction, and then it executes the next line of code, which is a bit of a bummer. But we can say drone get velocity, and so we can write a wrapper function that tries to move and then just waits until our velocity is 0. So that'll have to be a strategy, I suppose. One interesting thing, though, is it does seem like the drone will try a little bit to get around some basic obstacles. It won't do anything too crazy, but if there's like one block in the way, it'll generally manage to get around that, which is helpful because we have a couple of blocks on our farm that are there to cover up water sources. So maybe we'll make use of that. But I don't know why I closed the robot slaughterhouse. We can pirate the rest of this. I'm just going to copy this for the indices. So move to above chest, and then I just want to steal these numbers. So I want to start at slot 28 and end at slot 45. Yeah. So has count is robot count, blah, 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 blah. What I actually, so in this case, I'm not sure how many seeds we need. I think it's more than 64 though. So we're going to try and grab as many as we possibly can. So we're going to modify this somewhat, but we're iterating over the slots in our chest that we have dedicated to seeds. And what we're going to do is we're going to say, I'm going to say local current slot is 1, and yeah, drones have 8 they get 8 inventory slots for having that upgrade, which is weird because the robot getting the exact same inventory upgrade gets more slots. So I mean, whatever. Or actually, no, maybe it does. Yeah, no, I think it gets 16 slots if we give it the upgrade. So it's weird that they respond differently to the same upgrade, which has the same cost, but whatever. Okay, so if we have a count, let's say, oh yeah, we don't need to track current slot. Never mind. I screw this. I forget this multiple times. All right, because we can say robot.select. Well, we'll have to say drone.select. Ooh, does drone in theory should get select. We're gonna let me check that. Okay, drone does have the ability to select. So we will say has count equals robot count. If has count, then we don't want to necessarily break. We're going to say if drone.select equals 8, then break. Otherwise, we will say drone.select plus 1. And now I'm mad about the number of times that I'm calling this function, so I am in fact going to create a current select equals drone.select, and just so we don't have to call it multiple times, so we'll say current select. So if we're currently on slot 8 and we've already determined that we have 64 things, then we'll go ahead and say break. Otherwise, we will just advance to the next slot. So that part is simple enough. Next, we're going to see what is available in that slot. If available is greater than 1, then great. Go ahead and grab, yeah, we're doing exactly the same thing. We're just trying to fill up our seeds. Okay, so that gets us full up, I guess. Now we're going to go ahead and say move to, I'm going to say ascend to farm. I don't know. It's Future Me's problem to figure out what exactly that means. Next, but assuming that we've done that, we're going to go kind of up the tunnel and stay in the middle briefly, because this is the point where I want to shoot out the water dispensers. To do that, we have to send a broadcast signal. And I actually have to open up our water script to remind myself of how that even works. Modem.broadcast. Actually, wait a second. This exists here. Modem. There was an example that we kind of cribbed this from. Yeah, there we go. Okay, so M component modem open a port. Okay, so yeah, we don't have to have the port open to broadcast on that port, so that's fine. So we do need to have access to the modem. So we'll say local modem equals component dot proxy component dot list modem. And now we have the modem. So all we have to do once we have ascended to the farm is say m.broadcast, and we need to broadcast it on port 4723. And that's, in theory, all that we have to do. We might try sending this multiple times, though, because we did encounter that issue where not all of them fired always, which was kind of a bummer. If we look at, well, let's steal the sleep function real quick, because I'm definitely going to use that. I'm going to say until, let's see, repeat 5 until, okay, that's how we do things, to do repeat untils. So repeat m broadcast. I suppose maybe I can also say until true do. No, okay, it doesn't like that. But I can repeat something until a condition is met. So I'm going to broadcast and then sleep for 0.2 seconds. And if we look at the water script, the way that they're set up is that if they receive a signal, they're going to flush, they're going to wait 3 seconds and then flush. And in the meantime, they're not going to continue listening to more signals. So we can just broadcast over and over and over again for, I don't know, let's say 2 seconds. Oops, what did I just do? Yeah, we can broadcast for up to for say 2 seconds, so that anybody who didn't get the first message has the opportunity to get it. And I'm going to leverage we have computer uptime, which is kind of the clock time.now or clock.current or whatever. So I'm going to say local current time is computer uptime. And then I'm going to say computer uptime, oops, is greater than current time. Well, let's not call that current time, because that's misleading then. Start time plus 2. So go ahead and continue to broadcast. This will broadcast 10 times within the span of 2 seconds, or at least close enough to it. And then once it realizes, okay, it's been too long, then we'll go ahead and shut up and stop broadcasting so we don't end up double firing stuff. Okay, so now more future Kevin's problems. Navigate, let's say navigate farm layout. And that's presumably going to handle some movement. I'm actually going to pass something to this function, though. I'm going to pass, well, I'll pass a function right here. And we're going to say, here is what I want you to do each step of the way. So navigate farm layout's only job is going to be to move us around, and then it will yield to this function that we're passing in, just to kind of separate those two concerns. What we can do is take in drone place 0, and that's place down. We have stuff in our inventory. Oh, actually, no, we need to do some inventory management stuff. Yeah, okay. We can do, let's see. Actually, yeah, so we should robot.select 1 there. And now, yeah, we need to make sure that we have anything in our inventory. So fair enough, we can go ahead and do that. We will say if, well, actually, one thing that we do know, which is convenient because of the way that we're filling things up, is that if we run out of stuff, we know for certain that the next slot has stuff. And because we're not using 8 stacks of seeds every time, we don't have to worry about exploding the stack. So we'll say if, let's see, robot.count equals 0, then, okay, so this becomes really easy. Drone select +1. That's all we have to do to make sure we always are able to place down some seeds. And then, yeah, okay, so we'll place down some seeds. So we're saying, I'm calling this navigate farm layout function, and anytime that its job is going to be to navigate around the farm, but the actual planting, this is what planting looks like. We make sure that we update our inventory, then we place, and then all we have to do, I don't think there's any cleanup we have to worry about whatsoever, is return to charger. And those are all movement commands. That is incredibly tedious. But before we jump into making my life hell, let's, okay, so function move to above chest, and function, what else have I consigned myself to? Ascend to farm. Cool. And navigate farm layout. And this one accepts a function f, which we can go ahead and call, and then return to charger. Okay, so those are 4 functions that I have to sort of pace out and write. But the way that we're going to write them, we already have a sense of how these are going to work. So in the case of moving to the above chest, I'm going to actually write this one together because we're going to need to write a helper function to do this, and I'll make use of that. And I don't know, maybe it's helpful. Okay, so I happen to know, because it's the same as the robot, this drone is going to sit next to the robot, that we want to move 3 blocks forward. Although it's not 3 blocks forward, it happens to be 3 blocks in the positive C direction. Now, of course, we don't know our actual coordinates, but we do know, I mean, we have to infer the axes. So what this is going to look like is just drone move 0, 0, 3. But there's a problem with that, and that was, again, as I said, it doesn't block. It's not going to move and hold up the program until it's done moving. It's going to sit there and say, all right, I'm going to start moving, and then immediately it's going to jump back up here and do whatever it's supposed to. Yeah, it's going to select a slot, and then it's going to start trying to look for a chest, which it may not be hovering over just yet. So what we need to do is block until we hit, block until our velocity has stopped. So I'm going to go ahead and write a wrapper function. We won't call drone.move. I think I have that auto does that. And this will go ahead and call XYZ. So it'll pass the same arguments to drone.move. But then we can add the wrapper in there. So I don't have to add wrappers everywhere. So move 003. Drone move that. And then we're going to say repeat sleep 0.1 until drone.getVelocity equals 0. Okay, so that makes sure that we've slept for 0.1 seconds. So we're probably not going to break out of this before it starts moving, and hopefully that should avoid that problem. Yeah, so that shouldn't be too bad. Now yeah, returning to charge, ascending to farm. This is going to be interesting. I'm curious. I may be able to get away with certain things, like for example, the chest is just to the edge of where our tunnel is, so I could possibly get away with saying something like, "Well, I want to move." -1 in the z direction, so I'm back over a hopper, but then I want to move up by 5. I don't know, maybe that's I need to check, but maybe that's the right number. We'll have to see. It could be that I could combine these two things rather than having to do them in a single step. I think the drone tends to have a little wiggle room with things like that, because it's an entity, and so it can get away with that. I'm gonna have to test it out. We're just gonna have to see. Navigate the farm layout is gonna be an awful lot of move commands. This is gonna be a whole bunch of 4i equals 1 to 6, do, and then it's gonna be move 0 0 1 and then F. Yeah, because we're just gonna go through row by row and just do things that way, because it's the easiest that we can do. Would be great to be able to use our movement library here, but we'd have to rewrite that to fit with the drones, and I think that's going to balloon this to a level we don't necessarily want to be at. Okay, so just on the off chance that this happens to work on the first try, I definitely didn't forget to put the main loop in the main function. I wanted to make sure I was recording, so let's see. Boom. Okay, it's going over there. Okay. It went over there and it failed, but it did something. So that's a start. Oh no, what? What? Seriously? Did that just happen? Did that really just, have I actually understood? What? Okay, so I analyzed the robot and it nudged the drone and it nudged it. Okay. I think that's gonna do it for today. Clearly I typed robot when I meant to type drone at some point in the code. Probably where I copied over inventory stuff. Oh, meanwhile, you're in the middle of doing stuff. Let me get out of your way. I don't want to break your pathing. It's time for another feed, but of course you've got very little wheat to be working with, so I don't even know what you're doing. Oh man. Okay. Well, we'll do more debugging and get this all fixed up in the next episode, and I will hope to see you then. This has been Cheers Kevin, and thanks for listening to me drone on. Have a good weekend, everybody.